Join us as one of our lead programmers slash analysts take you on an exciting journey through space rocks. From rare meteorites up close to stunning visuals and hands on science experiments, discover the fascinating story of asteroids that helped shape our solar system and maybe even Earth itself.
I will be glad to show what's my collections related to asteroids. All asteroids split it in three big classes. First, it's rocks, asteroids from rocks. Second, asteroids from metals, ferrum and nickel mostly. And third, it is mix, rocks and metals and pallasite. People call this pallasite. Pallasite because was academicians from Germany who work in Russia, and he found huge meteorites in forest and something local uh, f- still working. And this is was pallasite, and this is academician was Pallas. He takes these meteorites, split it in pieces, sent to many European scientific people, scientists and institutes, and all people say, "Oh, it is pallasite." It means that meteorites from pallasite. It means that somebody found this, but Pallas was in good shape for distribution, as this is sample of pallasite. So it is right now in history. So let me show what I have in here. Actually, meteorites which we found in Earth, they represent all stuff which we have in space. So, for example, this is small dark stuff. It is piece of Chelyabinsk superbolide, very fresh. They blasted in February 15, 2013, and was um, meteorites in size 18 meters. 60 feet, 10,000 tons. And they split it in small pieces like this. This was melted and burned. They very dark. And they consist just from rocks. It is most minimum metal stuff, metal percent of asteroids, piece of asteroids. And this is asteroids or meteorites from metals, ferrum and nickel. This is from Argentina, Campo del Cielo, and a lot of pieces people found in this Argentina forest. And this is very nice sample. You see, melted all around, and it is not rusted. It is space metals, so they own rusted, not rusted. And this is famous pallasite. Pallasite, which have still in here, and you can see half transparent rocks olivine in here. You can here should I have you can see maybe okay broken a little bit. And this is very famous piece of asteroids. Um, this is found in Finland. 1 billion years ago was impacted 2 years. This is Monianalusta, and this is most oldest materials in Earth, more than 4.5 billion years. It is more than any minerals in Earth, and most oldest from all meteorites which we found in Earth. So this is officially oldest materials from space. And you can see very interesting structure in here. This is, people call this Widmanstetten pattern. Widmanstetten, it is also scientist from Germany who found this. It means that he cut meteorites and polishing and then put something in acid. And after this, they found very interesting crystallic structure. This is very specific space crystallization between nickel and ferrum, and mutual merging, some synergy between to this crystallic structure. And it's very specific. It means that in space, ferrum and nickel was melted and very slowly cooled in zero gravity conditions. and that's the reason why it's very specific stuff. So this is nice samples of what we have in space. And this is sample, of course, represented in all meteorites in years. And I can show interesting experiment with space and Earth rocks. It means that in here, this is also a piece of Chelyabinsk superbolide. And this is from superbolide from rocks, but 10% of metal, and you can see that magnetics balls stay enough and react for this stuff. Yeah, it means that this is space. Rocks have a serious magnetic capabilities. And actually our Earth was collected, was accreted from these space rocks. And it means that in average we must have something 10%, maybe more, ferrum in our Earth. But for example, this is limestone from Virginia Mountain. You can see zero interest to this limestone. So limestones have not any magnetic properties. But if we have mineral or something rocks from inside of Earth, for example, this is Hawaii rocks from volcanic eruptions, and these Hawaii rocks have something magnetic capabilities smaller than space rocks, but much better than other mineral from surface, Earth surface. So this is three rocks: space rocks, Earth rocks, and volcanic rocks. Show basic property of our Earth. So Earth was collected from space rocks, melted. All this ferrum nickel stuff collected in nuclears inside of Earth, and all outside have minimal level of metal stuff. That's show limestone and other minerals. But if you have volcanic eruptions who extract extract something inside Earth, they already have a larger level of ferrum and have something magnetic capabilities. So this is very simple, but show you basic paleontological facts about origin of Earth. So we can work with paleontology just in our table. Paleontology is not in space. Earth is planets. So anything about paleontology can be found in Earth, and something illustration from the SSAI rocks. And I think it is curious for children, at least.
These space rocks may seem silent, but they hold stories written across light years. To truly understand where they come from and where they're going, we turn to the power of data and visualization.
This is photos from Chelyabinsk. It means that Chelyabinsk superbolide, which was blasted in 2013, or 12 years ago. You can see a huge blast in here and clouds of plasma actually. Yeah, and this is asteroids. 60 feet asteroids was splitted in a lot of small meteoroids like this. And when this was blasted, it was little in south from Chelyabinsk, a city where I born, and they have millions residents in here. And my father and mother again was live in moment of this balites and saw this balites and shock waves was splitted window in his apartment. Yes, and people start looking what we have in this meteorites. Was February. for South Ural, it is a lot of snow, something about 1 meter snow. And when this rocks melted and burned, but they was not hot, they was warm. Was temperature enough for melting of snow. It makes like holes like this. And this is holes for meteorites, I think maybe 5 centimeters, large enough. You see, people keep these meteorites. And was melted and stay inside. And actually it was in top something melted snow. And people found this extract. Oh, it's not mouse, it is meteorites. And you can see a lot of meteorites was collected. Partially they moving to scientists, and scientists also have some expedition for collections. It means that Chelyabinsk sent couple expedition, and Moscow and people from United States. Jenniskens was in here. They also collected this is meteorites, and larger meteorites was extracted from Chibarkul Lake. It was with a table. It's 600 kilograms. But I'm working in SSAI, and I understand that space dust was stay in atmosphere. This is important. We must know what's physical properties of this dust, optical properties for calculation. It means that NASA scientists like Da Silva, and he asked me. We have a nice model for calculation, modeling, spreading of this space dust, but we need information about what's the optical property of these particles, etc. And I sent emails to Professor Chelyabinsk University Dudrov, who was my first scientific advisor, and asked, guys, meteorites is interesting, but a lot of museums in the world have meteorites, but nobody have space dust, which collected immediately after blast. So let's send somebody who can collect in the snow, and people who live in here say in specific level, the snow, any snowfall added extra layer in this huge snow, 1 meter depth. But specific days, meteorites, it was dark. So a lot of dust was in here. And I'm moving up to rector, Chelyabinsk University. And he organized a specific expedition with students and somebody from ecological department. And they collect a lot of snow from this level of dark, melted, filtering, and they collect something 100 gram of this dust. It is a lot. They sent me a little bit. I sent to other scientists, and we found a lot of interesting stuff in this dust, because in this condition, just a few seconds, which superbolide moving in atmosphere, they have huge temperature, pressure, very specific condition for crystallization. They found not diamond, but something quasi-diamond in here. They published a lot of huge papers about this with international quasars. I also was quasar, but not major, just number 10 or something. Yeah, but threats in this, was my discovery. It means that I have not any prejudice or some paradigm. I just take microscope and look at this as dust, and I can see, okay, this was definitely. Most important point was I found this was threads from rocks, which was connected between two pieces of rocks. They not stayed alone, just was connected with specific small pieces of rocks. So this definitely was work together. So they origin together. Yeah, and that was signature. That was formed just due to interaction between superbolide and atmosphere. This was cool. Yeah, it was fun, definitely fun. And after few years, all this research, etc., I told to scientists from Chelyabinsk State University, guys, let's write books about this. And 15 co-authors each wrote something specific parts, chapters of these books. And this books was published in small numbers in Chelyabinsk Space University. But Springer Praxis published this for all scientists in the world in English. And a lot of other such photos we can find in these books, very well illustrated. So that's our input in asteroidal problems, how dangerous asteroids for us. I mean, that's a super bolide show. Okay, asteroids in 20 meters already dangerous. 20 meters, 100 meters, very dangerous. Don't ignore this. And just today news, Vera Rubin telescope start working in South America. One specific goals for this telescopes, collection of asteroids and special asteroids closer to years. In just first tested samples, they found something 1,000 new asteroids and 7 asteroids which close to potentially dangerous for years. So it means that Chelyabinsk superbolide just change paradigm, push humanity for thinking, okay, space, it is not just nice pictures, it can be dangerous. It can be dangerous. So be serious with this, not ignore this space. So space can be hard.
Every orbit mapped, every fragment analyzed begins with a curious mind behind the scenes. But sometimes the universe gives back, honoring those who help us unlock its secrets. This asteroid, it carries a very special name.
In Crimea Observatory of work famous discoverer of asteroids, Nikolai Chebnych. He famous. A lot of people in astronomy know Nikolai Chebnych. He discovered 100 asteroids, and I worked for Crimean Observatory about 10 years, and I know him well. And in some way, something 1995, I got email from him that we would like name asteroid of 4,654. He mentioned, pay attention to the two first numbers and second two numbers, so total it's 100. Okay. With your honor, I was so pleased and surprised. So it means that nobody can name his discovery by own name. So it must be doing something. If you found comets, comets will be your name. It is just officially. But asteroids, somebody must be told about this. And he sent specific petition to International Astronomical Union. So that's special commission who names this, and they looking without any politics, without any not nice stuff, but a lot of people, for example, Asimov, have asteroids pretty close to mine, 5,000 something. Clark, and I think it is also Chernych named this. So, and here give me this is nice gift. So in all astronomical database, we have asteroids 4654, Gorkavyi named in cosmogonist who developed something model for satellites, etc. And it is 3.5 kilometer. It is pretty close war to astronomical units, just above Mars, and I think very slowly rotated, 22 something hours. So I think he have not satellites. Usually, fast rotating asteroids can have satellites, but low rotating asteroids have not. But it is, it is gift more than anything what can be can't be treated. That's great. Thank you. He already passed away, Nikolai Stepanovich. Yeah, but he was a great man. All life was dedicated to astronomy, to Earth, to sky, to space. Yes, that's interesting facts for my biography.